This is All India Radio. Whispers of the Wind. All India Radio, in collaboration with Vigyan-Prasar, presents science serial Whispers of the Wind, based on understanding and managing climate change and global warming. Let's listen to episode number 18, titled Evidences of Climate Change.
Ratna,
Yes, sir.
Kumar,
Yes, sir.
Srishti,
Yes, sir.
Vishal,
Yes, sir.
Mary,
Yes, sir.
Akash.
Yes, sir.
Okay, so there are 30 students today. I think I should count also. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I now find that there are only 26. It means somebody has given proxy attendance for 4 other students. Dear students, you have given voice for your friends for showing their present, isn't it? Oh no. This is just not good. If you accept who are the absentees, then only I will teach you a very important topic. Okay, so I will leave you to study other evidences of climate change without my lecture. Okay?
Sorry, sir.
Just to have fun, we have done this, sir. Since you are very kind to us, right from the beginning we did, sir.
So far you have not punished us, sir. We'll tell you who are the absentees.
Okay, fine. I will not punish you today.
Thank God we are safe.
I was also a student once. I did the same mischief. But it is my duty to correct.
Thank you, sir.
But I wish to engage you in today's lecture. But before that, you have to tell me who are the proxies today.
Me,
Okay, Rahul.
sir.
Mary.
So me also.
Gargi?
Sir.
Okay, Akash. Very good. So, today our lecture is about evidences on climate change which had happened in the past. In this topic, I will ask questions and you have to ask questions as well.
Sir, I have a question. What are the evidences and are they real, sir?
Yes, they were real at that time and they help us to understand the climate change happened at that time.
Oh, great, sir.
So, before starting, I want one student to come in front of the class and stand next to me. So, who would be the first one? Mary,
Yes, sir.
please come in front.
Okay, sir.
Okay, so Mary, we will dialogue about ice core data analysis. But for that, you have to go to Antarctica.
Sir, I am shivering.
Okay, class. But why are you shivering, Mary?
Sir, why did you select Antarctica?
Why? When you can give attendance for Ratna, why can't I send you to Antarctica?
Please tell me, why did you select Antarctica, sir?
Mary, it is the place where some scientists are getting the ice core data. There are other places also.
Oh.
But we take Antarctica as the place where lots of experiments are going on for the climate change studies.
Okay, sir. Now please clarify what is ice core?
Ice core can be taken from ice sheets and glaciers near Earth's north and south poles formed from years and years of accumulating snowfall. The weight of the snowfall compresses down the previous layers of snow and after many years, all of this pressure helps to form glacial ice. In some areas, these layers result in ice sheets that are several miles thick.
Really amazing, sir. How do they take the ice core from these several kilometers thickened ice sheets?
Mary, researchers drill ice cores from deep, sometimes up to nearly 1 mile or more than 1.6 kilometers.
Oh.
inside the polar ice sheets in Greenland and Antarctica. They collect ice cores in many locations around Earth to study regional climate variability and compare and differentiate the variability from global climate regime. The sample collected from the ice called ice cores, which holds a record of what our planet was like hundreds of thousands of years ago.
But sir, how do we learn about the climate of the past through ice core?
Each layer of ice tells a story about what Earth was like when the layer of snow fell. For example, Legrand says as snow deposits onto a growing glacier, the temperature of the air imprints onto the water molecules. The icy layer also holds particles, aerosols, such as dust, ash, pollen, trace elements, and sea salts that were in the atmosphere at that time. Yes, and these particles remain in the ice for thousands of years later, providing physical evidence of past global events such as major volcanic eruptions. Additionally, as the ice compacts over time, tiny bubbles of the atmosphere, including greenhouse gases like carbon dioxide and methane, press inside the ice. These air pocket fossils provide samples of what the atmosphere was like when that layer of the ice formed. Scientists can directly measure the amount of greenhouse gases that were in the atmosphere at that time by sampling these bubbles.
Okay, sir. But how do ice cores help make predictions about future climate change?
Mary, scientists also use ice core temperature data to validate climate models that predict Earth's future climate. Let me tell you, according to Legrand, a woman scientist, the climate model is like a laboratory inside a computer. Scientists build all of the existing knowledge about how the atmosphere, ocean, land, and ice work into this special laboratory. They also have to add in any variables that may alter the climate system at the different points in time, such as Earth's location in its orbit and how far it will be from the sun. Climate models are designed to reproduce the relatively stable climate that people have observed for the past 160 to 170 years. It sounds like a long time, but this used to be possible in the days of Farmer's Almanac because Earth's climate system was quite stable. However, predicting the climate of the future is a bit more complicated these days. She said, the climate for the next century will be beyond the range of the climate that we observed for the last 160 years. To test the climate models under these very different environmental conditions, a scientist tests the models by simulating past climates. Ice core records are an essential part of creating and checking these simulations.
But sir, how do we know it's old and which is the oldest ice core?
The oldest ice cores from East Antarctica provide an 800,000-year-old record of Earth's climate. And how do we know they are that old? Each season, snowfall has slightly different properties than the last. These differences create annual layers in the ice that can be used to count the age of the ice, just like rings in the tree.
As per your explanation, I could understand that the carbon dioxide captured in the air pockets of the ice core differ from period to period.
Correct.
By analyzing concentration of carbon dioxide at different levels of ice core, we may estimate the amount of carbon dioxide present at that time. Is it right?
That's true, Mary. You have explained more than me. Congratulations.
Thank you, sir.
So now, who will be next one to come? Rahul,
Yes, sir.
Okay, so Rahul, what do you know about pollens?
It is produced from the plant during reproduction.
Very good. Are you aware of the details?
No, sir. But I touched some anthers of the plants. It looked like a dust in yellow colors. My uncle from Tamil Nadu Science Forum has shown it through the foldscope, which was wonderful, sir. I have seen different types of pollen grains with different shapes, sizes, colors, etc. Really, it was amazing.
That's very nice, Rahul. Now I am going to tell you about the pollen of million years ago.
I'm eager to know, sir.
The scientists working on climate change collected by ice core drilling or from the floors of the lakes or from the sediments at the bottom of the ocean.
Can they exist for millions of years?
Yes, they have hard coats, resistant walls, though they are very minute and could be seen in the detail through microscopes only. They are very resistant to decay. For examples, some pollen collected from East Africa were 3 million years old.
Wow.
3 million? Sir, really surprising. They are very minute. How would they be collected?
Rahul, though they were very minute, but they were available in plenty.
Oh,
For example, a pine tree with one branch could produce 350 million pollens.
350 million pollens.
Yes, the abundance is the criteria by which we could collect. It is mainly by drilling into the ice sheets in the polar regions, like drilling for bowels. Here, they take out the dug ice in a careful way and find out the sediments of pollen in the column of ice.
Oh, now I'm able to understand, sir. But how do they find out the relationship with climate change in the pollen grains?
Very good question, Rahul. The size and shape of the pollen grains were analyzed from the sample taken. The size and shape of the pollen grains depend upon the temperature of that period. The fluctuating type and distribution of pollen grains will tell you the local and regional histories of vegetation and climate.
Oh, which means the temperature determines the shape and size of the pollen grains. True, sir?
Exactly, you are very much correct. Not only pollen grains, but there were foraminiferas, which were collected from the floors of the sea, which would also tell the temperature of the sea.
What are foraminiferous, sir?
These are microscopic unicellular living organisms like amoeba. They are abundant in the sea today also.
Oh.
They were very abundant in the past as well. They are not only abundant, but they are diverged in different categories as well. The diversity of the foraminiferous depend upon the temperature of the sea. By their diversity in size and shape, they could indirectly derive the temperature of the sea and know the temperature changes over the years.
Sir, really unbelievable.
But you do have to believe it because it is evidence-based.
Yes, sir.
Okay, well done, Rahul. Now you can go and take your seat. So, who is the next mischievous?
Sir Gargi.
So, Gargi, please come and join us.
Yes, sir, coming.
So, another evidence past climate change is forest genetic resources. Let us start with your question.
What do you mean by forest genetic resources, sir?
Forest genetic resources are genetic material of shrub and tree species of actual or future value.
Oh, but how do these forest genetic resources differ from each other?
See, forest genetic resources are species specific. Hence, we can see a diversity of genetic resources in a given area.
Oh.
This diversity will help to adapt to climate changes in that area. They are also undergoing changes due to climate over the period of 50 to 100 years.
Really?
So we predict if climate change occurs during the next 50 or 100 years, it will have an impact on the distribution of forest tree species and composition of the forests.
Okay. So, then how do we know climate change occurred in the past and influenced the genetic resources?
Very good question. That's why we took this discussion. Climate change might have indirectly affected the plant genetic resources through effects on phenology, breeding systems, plant pollinator, and plant seed dispersers interaction, and etc. By collecting the genetic resources of plants at that time in different times, we can predict the climate of that era.
If so, sir, what is the use of this study of the past?
This is another good question, I must say. If we know the climate change and its impact on genetic resources, we could protect the existing genetic resources by in situ or ex situ conservation.
So, you taking to another realm, in situ and ex situ conservations? What are these?
And don't worry, it is some conservation methods. It is natural or artificial method of conservation. But this is not our topic now. We should move on. So, Gargi, you can go and sit.
Thank you, sir.
So who is the last one?
Sir.
Okay, Akash, I can see you.
Yes, sir.
Please come here. So, I will now tell you another evidence for climate change, that is dendroclimatology.
Sir, the word itself threatens me so much.
Akash, don't worry. The word is somewhat threatening, but it is a simple phenomenon of explaining about the study of annual rings in the trees.
Oh, I have studied the annual rings in the larger trees, sir. Every year, the tree forms a ring by which we can measure the age of the tree.
You are correct, Akash. This is the study of annual growth of trees and the consequent assembling of long and continuous chronologies for use in dating the wood is called dendroclimatology.
Oh.
The study of relationships between annual tree growth and climate is called dendroclimatology. It will give us a clear picture of the climate at that time. The ring formation is nothing but the growth of a tree. It depends upon the sunshine, precipitation, temperature, wind speed, and humidity. By analyzing the ring pattern, we can assess the climate of that period. And the tree ring width depends upon the climate.
Sir, how do they analyze the past tree?
It's done by isotope measurements. Tree growth, which records such isotope variations, should preserve a record of past temperature fluctuations using oxygen isotopes and hydrogen isotopes variation. Beyond that, we need to go in detail.
And what else are we supposed to discuss, sir?
Finally, about fossils and climate change.
Fossils and climate change. Sir, I know the fossils are the remains of the past animals and plants.
Exactly, you're very much correct. Fossils are of two kinds. They can be the actual full remains of organisms or a trace of the organisms like teeth, bones, wings, such that we can list,
Okay.
Sometime we may get flesh of the dead animals if they were preserved in deep ice sheets.
Sir, how does fossil formation takes place?
Most fossils form when an organism dies, their body buried with sediment. Layers of sediment slowly build up. The sediment is buried with even more sediment.
Oh.
Over the period of time, the sediment turns into sedimentary rock. The remains of the plant or animal also turns to rock. The remains are replaced by minerals. They become later on to stone. And this process is called fossilization.
Fossilization.
Correct. There are other ways of fossilization in the form of molds, casts, footprints, and embalmment in resin, and etc.
How are fossils helpful in understanding the climate of the past, sir?
Good question. First, the life on Earth has been changed over times because fossils in different periods are different. And new one also found. Fossils in younger rocks look like animals and plants that are living today. Fossils in older rocks are less like the present living organisms.
Sir, how to understand the climate from fossils?
It is done by finding out the fossils in different regions of the earth. We can estimate the climate of the region. For example, let's say fossils of plants are found in Antarctica. Now, Antarctica is covered with ice. This means that Antarctica was once much warmer than it is now. These fossils tell us about the Antarctica's past climate. And there are fossils of sea organisms in Mount Everest, which shows that Mount Everest emerged from sea by uplift of the ocean floor.
Very authentic evidences you have given, sir. Thank you so much.
You're most welcome, students, and thank you to you too, students. We have had a wonderful class interactions regarding the other evidences for the climate change that had occurred in the past, didn't we?
Yes, sir.
I'm sure now you are being enlightened and you will keep that knowledge to yourself.
Yes, sir.
We had a great session with you, sir.
Thank you so much.
Okay, thank you to you too, students. But do remember, no proxies from now on.
Whispers of the Wind. You were listening to the 18th episode of this science serial produced by All India Radio in collaboration with Vigyan-Prasar, titled Evidences of Climate Change. This episode was written by P. Rajamanikam. Coordinators were Dr. Nakul Parashar and Dr. Birendra Kumar Tyagi. This episode was directed by Sudarshan Kumar, presented by Dilip Jha, and assisted by Naveen Kumar. Participants were Gaurav Devgan, Arjun Sharma, Vasundhara Bose, Gargi Sahijani, and Avani Sharma. Hey listeners, please stay with us. Here are 2 questions for you. The lucky winners will get attractive prizes from Vigyan-Prasar. The first question is, what are the foraminifera? And second question is, how does fossil form? You can send your answers by simple post. Our address is Science Serial, Whispers of the Wind, Director Vigyan-Prasar, A50 Institutional Area, Sector 62, Noida 201309. You can also write on our email ID radio@vigyanprasar.gov.in. Please do write or mail us your full name, age and profession. If associated with Science Club, do let us know the membership of your club. If you have any query or question, do not hesitate to write to us. We will be back again with the next episode of this science serial, Whispers of the Wind, same day, same time next week. Till then, goodbye.